All right, lesson 9, direct variation. This is our last lesson in this chapter. All right, so direct variation is kind of a scary sounding word, but we're going to find it's actually pretty much the same thing as a proportional relationship. We're just going to sprinkle in a little bit more vocabulary here, and we're going to look at a formula that we're going to use to represent direct variation or represent proportionality. So let's look at our real world link. It says the distance d a car travels after t hours can be represented by this equation d equals 65t. The table and graph also represent the situation. So basically our distance is equal to 65 times however long the car is moving. All right. So if it goes 2 hours, you'll travel 130 miles, 3 hours, 105, 4 hours, 260, and so on and so on. And you can see that represented in the chart here with the 3 points graphed right there, there, and there. All right, so let's fill in some of these blanks that they're asking for. So remember, distance traveled over driving time. So the first ratio they set up is if you travel 130 miles, it will take you 2 hours. Or if you drive for 2 hours, you'll go 130 miles. Well, if you've traveled 195 miles, how long have you driven? Well, if we look up here at our chart, we can see 195 on that point right there comes down to 3 hours of travel time. And if we've traveled for 4 hours in that last one, how far have you gone? Well, if we go over here to our chart, we go to 4 and we go all the way up there. We find that point right there tells us that after 4 hours, you've traveled 260 miles. So they say, what's the constant ratio? All right, how many miles do you go in 1 hour? In 1 hour? Well, we can find that constant rate of change. All right, that's plus 1 hour. That's plus 1 hour. That's an increase of 65. That's an increase of 65. So our change is 65 miles per 1 hour. And we could have done that also by taking any one of these points and simplified them. Divide by 2, divide by 2, 65 miles per hour. So that was our constant ratio. Number 2 here says the constant rate of change, or the slope. Remember, we've learned those two terms as well. Constant rate of change and slope of the line is your change in miles over your change in time, which is equal to, they selected the 2 points 3, 195 and 2, 130, subtracted their change in y over their change in x, and they found that this gives you 65 over 1, or 65 miles per hour. Well, that sounds familiar. So number 3 says write a sentence that compares the constant rate of change and the constant ratio. Well, guess what? This is a pretty easy sentence. They are the same. So constant rate of change and the constant ratio are exactly the same idea. So direct variation. What is direct variation? Well, in technical terms, it is a linear relationship, is a direct variation when the ratio of y to x is a constant represented by the letter k. We say y varies directly with x. So you can write that as y over x is equal to k, or y equals kx. And this is kind of our agreed upon equation that we use for direct variation. All right, so for example, you could have an equation that looks like this, y equals 3x. That's a direct variation equation, and it means that your y value is always equal to 3 times the x value. That's what that's saying. Or for example, the one in the graph over here, y is equal to 2 times your x value. So if your x value here is 1, whatever that times 2 is 2, so 1, 2 is your y value right here. So you can see that you have a point of, not 2, 1, but 1, 2. So let's look down here. It says when two variable quantities have a constant ratio. And remember, we said a constant ratio is exactly the same as a constant rate of change. And we said a constant rate of change is exactly the same thing as a slope. So if two compared quantities, for example, speed versus distance, all right, that kind of thing, if they have a constant ratio, all right, one changes as the other change, all right, we say they're proportional. They have a slope. They have a constant rate of change. This is exactly the same as what we call direct variation. The constant ratio, or the rate of change, or the slope, or whatever you want to call it, is called the constant of variation. And the constant of variation is also known as the constant of proportionality. So I know, super overwhelming. It seems like a whole lot of terms, but the funny thing is they all kind of mean the same thing. So your constant of variation is the same thing as your constant rate of change or your slope. Your constant of proportionality is the same thing as your constant rate of change or your slope. So in a direct variation equation, which we said above was that y equals k times x, the constant rate of change or the slope is assigned a special variable k. So k is going to be that number, whatever that ratio is, whatever that constant rate of change is, whatever that slope is. They're all the same thing. They mean the same thing, but they'll be represented by the value k. So let's use this a little bit, and it'll probably sort of fall into place here. When we start using and finding these things, you're going to see how much they relate and pretty much are the exact same thing as what we've done leading up to this example here. All right, so it says the height of the water as a pool is being filled is shown in the graph. Determine the rate in inches per minute. All right, so let's think back to what we've already done. It's asking about the rate in inches per minute. So that means inches per 1 minute. So what are they asking for? They're really asking for a unit rate. All right, a unit rate. We did unit rates way long time ago here already. All right, and looking at this graph, well, I see it's a straight line. And I see that it travels through the origin. So I automatically know that there's a proportional relationship, all right? Because remember, we learned that when you graph all the points in a table, if they form a straight line and go through the origin, it's a proportional relationship. And we know that proportional relationships have a slope or a constant rate of change, meaning we can find the ratio for any one of those points, and that should tell us what the slope is. All we got to do is find the change in x and the change in y. All right. So, as it says down here, since the graph of the data forms a line, the rate of change is constant. Use the graph to find the constant of proportionality, or what ultimately will be the slope. So in this particular case, since we know there's a proportional relationship, we can simply find the ratio of height to time. So in our first point, which is right here, our height is at our height is 2, and our time is 5 minutes. And if we found that as our unit rate, remember we want the denominator as 1, we find it 0.4 to 1. All right, and you could do this with any point. I'll do it with the big one over here, our 20 and 8. So that's 20 and 8. Divide by 20. Divide by 20. We find it's the same thing, 0.4 to 1. So that means the pool fills at a rate of 0.4 inches per minute. So let's look at an example using that equation we talked about for direct variation, y equals kx. It says the equation y equals 10 times x represents the amount of money represented by Y, Julio earns for X hours of work. Identify the constant of proportionality. Explain what it represents in this situation. So that's kind of our Y equals KX is our standard format. This is where we don't have any values. Well, they're telling us that the equation in this case for Julio is Y equals 10X. Well, if we want to know what the constant of proportionality is, guess what? It's just K. So what value is in place for K? Well, 10. So the constant of proportionality is 10. What's it telling us? It's telling us that Julio earns $10 for every hour he works. For every 1 hour worked. So again, that's the same as our constant rate of change. That's the same as our slope if we were to have a graph of this. Okay, so how can we determine if a direct variation exists? All right, not all situations with a constant rate of change are proportional relationships. Likewise, not all linear functions or straight line graphs are direct variations. So just like we determined whether something was proportional, we're going to use that same logic to determine whether a direct variation occurs. So in this example, it says pizzas cost $8 each plus a $3 delivery charge. Show the cost of 1, 2, 3, and 4 pizzas. Is there a direct variation? All right, so for one pizza, it costs $3 for the delivery charge plus $8 for the pizza. So that's a total of $11. If we bought 2 pizzas, well, now it's $8 for one pizza, $8 for a second pizza. That's $16. But don't forget, we have that $3 delivery charge, but we only have to pay that once. So that puts us up to $19. If we have 3 pizzas, well, it's $8 for each pizza. So that's 8 times 3, which is 24. But then we have to add that $3 delivery fee. So that's $27. All right. And then if we had 4 pizzas, well, that's $8 for 4 pizzas, which is $32, but we still have to pay the $3 delivery fee. So that's $35 for the 4 pizzas. All right, so let's graph that information with a nice ordered pair. So we've got 1 pizza for $11, 2 for $19, 3 is $27, and 4 is $35. All right, so we got a pretty nice looking graph right here like that. Well, I would ask you, is this proportional just by looking at the graph? And you would say, well, it's a straight line, but it doesn't go through the origin. Well, if it doesn't go through the origin, it can't be proportional. Well, the same thing is true for direct variation. It is not a direct variation, therefore there's no constant ratio. And we can compare our ratios of each one of these to find that as well. So we have $11 for one pizza. That reduces to 11 over 1. We'll try it with the next one. $19 for 2 pizzas. What does that reduce to? Well, that reduces to 9.5 over 1. Well, 11 over 1 is not the same as 9.5 over 1. So the ratio is not constant. Therefore, there is no constant of proportionality. Last example. So we're going to determine whether the linear relationship is a direct variation. If so, state the constant of proportionality. So we have time X over wages in dollars Y. So to do this, let's compare the ratios of time to wages, or excuse me, wages to time, and see if we find a common ratio. Because remember, a common ratio, same as a constant rate of change. If we have a constant rate of change, we're going to have some proportionality. All right, so here we go. Wages, 12, time, 1. That one's reduced, 12 over 1. Let's look at the next one, 24 to 2. What does that reduce to? Both of them can be divided by 2, giving you 20, not 21, but 12. All right, that's looking pretty good. Next one, 36 over 3. What do they both divide by? 3, giving you 1 and 12. Ah, I'm seeing a pattern. Last one, 48, 4 reduces to 1 over 12. So as you can see, they all have a common ratio of 12 over 1. So the constant of proportionality, which we use as k, equals 12 over 1, or simply 12. There you go. So really, same idea as proportionality. Find the slope. It'll give you the exact same answer. All right, check out your guided practice, and we'll work on this tomorrow.